Geometrical meaning of the zeros of a polynomial. A real number k is a zero of a polynomial f of x if f of k is equal to 0. To understand the meaning of geometrical meaning of the zeros of a polynomial, first we have to learn the geometrical representation of a linear polynomial, quadratic polynomial and cubic polynomial. Graph of a linear polynomial. For linear polynomial, the graph of y is equal to ax plus b is a straight line. Let us understand it with the help of an example. Let us have an equation y is equal to 3x plus 6. So for different values of x, the corresponding values of y are 0, 6, -1, 3 and 1, 9. Now we plot these points one by one on a graph paper as shown. Now we join the points and we get a straight line. From the graph, we can see that y is equal to 3x plus 6 intersects x-axis at -2, 0. If 3x plus 6 is equal to 0, then it gives x is equal to -2. That means zeros of polynomial 3x plus 6 is -2. So, x coordinate of the point where the line intersects the x-axis is also -2. Hence, zeros of the polynomial is the x coordinate of the point where the graph of y is equal to 3x plus 6 intersects the x-axis. So, for a linear polynomial of ax plus b, where a is not equal to 0, the graph of y is equal to ax plus b is a straight line which intersects the x-axis at exactly one point, namely -b by a, 0. Hence the linear polynomial ax plus b, where a is not equal to 0, has exactly 1, 0, namely the x coordinate of the point where the graph of y is equal to ax plus b intersects the x-axis. Graph of a quadratic polynomial. Let us draw the graph of a quadratic polynomial x square minus 5x minus 6. Now let y is equal to x square minus 5x minus 6. So, for various values of x, the corresponding values of y are -2, 8, -1, 0, 0, -6, 1, -10, 2, -12, 5, -6 and 6, 0. Now we plot these points one by one on a graph paper and join them as shown. We get the graph for the quadratic polynomial. From the graph, we can observe that the coefficient of x square in y is equal to x square minus 5x minus 6 is 1, which is a positive real number. So the parabola opens upwards. The parabola intersects x-axis at 2 points, -1, 0 and 6, 0 respectively. So this quadratic equation has two distinct zeros at -1 and 6. By algebraic method, we can factorize the given polynomial into two distinct linear factors. That is, x square minus 5x minus 6 is equal to x minus 6 into x plus 1. So the parabola intersects x-axis at 6, 0 and -1, 0. Now we study the graph of a cubic polynomial. Consider a cubic polynomial y is equal to x cubed minus 4x, and for various values of x, we get the corresponding values of y as shown. Now plot the points one by one on a graph paper and join them as shown. We get the graph for the cubic polynomial, and from the graph we can observe that y is equal to x cubed minus 4x intersects the x-axis at 3 points, -2, 0, 0, 0 and 2, 0. Hence -2, 0, 2 are three distinct real zeros of this polynomial. From the examples discussed above, we can conclude that in general, a polynomial of degree n can have at most n zeros. Or we can say, geometrically, zeros of a polynomial is the x-coordinates of the points where its graph intersects or touches the x-axis.